Hi everyone, welcome to the fourth series of software manual testing. In the last session, we covered important questions regarding few of the major phases of software testing life cycle. In this session, we are going to cover bug or defect life cycle, bug templates, different types of black and white box testing, and few more important concepts. Here is the first question. What is the difference between error, bug, defect, and failure? So let's understand the differences. Error, a mistake made by the developer, human error. Bug, a flaw or issue in the software due to an error in the code. Defect, a difference between expected and actual behavior identified during testing. Failure, a situation where the software fails to perform as expected during execution. Error, incorrect coding or misunderstanding. Bug, error in the code or logic. Defect, errors or bugs that are identified in testing. Failure, bugs or defects in the code that affect functionality. Error, development phase. Bug, development or testing phase. Defect, testing phase. Failure, execution or runtime phase. Error causes defects or bugs. Bug results in malfunctioning software behavior. Defect causes unexpected behavior or failure to meet requirements. Failure leads to the failure of the software to meet user expectations or business requirements. Error, writing incorrect code logic. Bug, system crash when a button is clicked. Defect, user unable to log in due to incorrect validation rules. Failure, application crashes when a user tries to log in. So remember, error happens first, which introduces a bug. Bugs are found as defects during testing, and if left unfixed, they cause failures in real-time usage. Now, next question, what is defect/bug life cycle? Let's discuss on different stages of defect life cycle. The bug defect life cycle refers to the various stages or phases a bug goes through during its life in the software development and testing process. Step 1, new. When a tester finds a bug and reports it, its status is marked as new. At this stage, the bug has not yet been analyzed. Step 2, assigned. The bug is then assigned to a developer for investigation and fixing. Step 3, open. Once the developer accepts the bug, it moves to open status, meaning work has started to fix it. Step 4, fixed. After resolving the issue, the developer changes the status to fixed. The bug is now ready for testing. Step 5, verified. The QA or tester checks the fix. If the bug is no longer present, it is marked as verified. Step 6, closed. If the tester confirms the bug is completely resolved, the status becomes closed and no further action is required. Step 7, reopened. If the bug still exists or the fix doesn't work, the tester reopens the bug and it goes back to the developer. Step 8, deferred. Sometimes a bug is valid but not critical for the current release. In that case, it is deferred for future attention. Step 9, rejected. If the reported issue is invalid, not reproducible, or not actually a defect, it is marked as rejected. So the bug life cycle flows like this: new assigned open, fixed verified closed, and depending on the situation, a bug may also be reopened, deferred, or rejected. Now move on to next question. What is bug report template? A bug report template is a structured document used to log and track software bugs or defects found during testing. It makes sure all necessary details are captured so that developers can reproduce, analyze, and fix the bug efficiently. Key fields in a bug report template: 1. Bug ID, a unique identifier for the bug, usually auto-generated by the bug tracking system. 2. Description, a clear explanation of the bug, including what was expected and what actually happened. 3. Steps to reproduce, a step-by-step guide that allows developers to recreate the bug easily. 4. Expected result, the behavior that should have happened. Example, user should be redirected to the dashboard. 5. Actual result, the behavior that actually occurred. Example, application crashes. 6. Severity, the impact of the bug on the system. Example, critical, major, minor, or trivial. 7. Priority, the urgency of fixing the bug, example, high, medium, or low. 8. Environment details about the system where the bug occurred, such as OS, browser version, or device info. 9. Attachments, screenshots, logs of videos that help in understanding the bug better. 10. Comments, any extra notes, clarifications, or discussions about the bug or its fix. So, a bug report template helps testers provide complete information and makes developers' work much easier in reproducing and fixing the issue. Now, let's discuss bug report with a simple example considering an web application. Field, bug ID. Here the bug ID is 101, a unique number generated by the tracking system. Field, description. The issue is the login button does not redirect the user to the dashboard. Instead, the page just refreshes without logging in. Field, steps to reproduce. Step 1, open the app in Chrome browser. Step 2, enter valid username and password. Step 3, click the login button. Field, expected result. The user should be redirected to the dashboard after successful login. Field, actual result. But instead, the page refreshes and the user stays on the login screen. Field, severity marked as major because login is a critical feature. Field, priority set as high because this bug needs an immediate fix. Field, environment, Windows 10, Chrome version 117.0. Field, attachments, includes a screenshot of the login page after the click and an error log file. Field, comments. The issue occurs only in Chrome, but it works fine in Firefox. So this is how a bug report looks in practice: clear, detailed, and structured. It helps developers easily reproduce the issue and provide a fix quickly. Here are a few more examples of bug report template. Now, move on to next question. What is severity and priority of a defect? Severity means how much the defect impacts the application. Critical, complete shutdown, nothing can proceed. Example, shop tab not working. Major, some key functionality broken but system still partially works. Example, cannot add a few products to cart. Medium, application shows undesirable behavior but is still usable. Example, checkout page opens without selecting any orders. Low, minor issue, no major breakdown. Example, cart clears on page refresh. Priority means the urgency to fix the defect. High, must be fixed immediately. Medium, should be fixed soon but not immediately. Low, can be fixed later or in future releases. So remember, severity tells us how serious the problem is, while priority tells us how soon it should be fixed. A bug can have high severity but low priority, or low severity but high priority depending on the situation. Now, next question. Give an example for low severity and high priority defect. Here is the answer. Scenario. On an e-commerce website, the company name / logo is spelled incorrectly on the homepage header. Severity, low. The application works perfectly fine. No functionality is broken. Priority, high. Needs to be fixed immediately because it impacts the company's brand image and creates a poor user impression. So, the application is still functional, low severity, but the issue must be corrected quickly, high priority. Now, move on to next question. Give an example for high severity and low priority defect, and the answer is scenario. In an e-commerce website's admin panel, the generate yearly sales report feature crashes the system. Severity, high, it's a critical functionality because report generation is broken. Priority, low. Since this feature is used only once a year and the release is focused on customer-facing features, the fix can be scheduled later. So the defect has a major impact, high severity, but it's not urgent to fix immediately, low priority. Now, move on to next question. What are the different black box test case design techniques in stlc? Now, let's discuss two important black box test case design techniques in stlc. First, boundary value analysis or BVA. In this technique, test cases are designed around the boundaries of input values because most defects occur at the edges rather than the middle. For example, if an age field accepts values from 18 to 60, we test values like 17, 18, 59, 60, and 61 to ensure the system behaves correctly at boundaries. Next, equivalence partitioning or EP. Here, we divide input data into different partitions, valid and invalid. Instead of testing every single value, we test one representative value from each partition. For the same age example, valid values are between 18 and 60, so we can test 25 as a valid input. Invalid partitions would be below 18, say 15, and above 60, say 65. This way, we reduce the number of test cases while still ensuring complete coverage. So, while BVA focuses on boundary limits, EP focuses on grouping inputs into classes for efficient testing. All right, that brings us to the end of part 4 in our series. In this session, we covered some of the most important questions and concepts in software testing. In the next part, we'll continue with more interesting and important topics that will strengthen your understanding further. I hope all the concepts we discussed so far are clear to you. Keep revising, keep practicing, and I'll see you in the next session. Please comment below for any clarifications or queries. For mock interviews, online classes, or for any queries, you can contact us at the email ID provided. Don't forget to follow and subscribe for upcoming videos. Happy learning.